To help you think in reactive programming, we need to understand not just what event streams are, but especially why we should use them. To me, it boils down to one simple reason. It allows you to specify the dynamic behavior of a value completely at the time of declaration. Now we're going to code an example here, but I'm going to write that property down because it's really important to understand it, and also it might be better to grasp once it's written down. Let's see the opposite example of this. So let's say you have a variable a, which has initially the value 3, and then you have a variable b, which is 10 times a. And if we console log out b, we will see 30. And then let's say we change a to be 4, and if we console log b, b is still 30. It didn't catch up with this new value of 4 because it's statically declared as 10 times a at the time that this line passed through the flow of control. So what we need to do is actually again set b to that formula, and now when we console log b, we see 44. But if you noticed, I made a typo here. Instead of 10, I wrote 11. So this means that b, even though it's a value evolving over time, right? It's not always, it's not a constant. This declaration here does not specify the dynamic behavior of that value b at the time of declaration, because later I just say it's 11. So ideally what I would want is that I just say that b is always 10 times a, and whenever a changes, then b will be 10 times a's new value. So that is what we can accomplish with event streams. So let's say that I have stream A is an event stream of just the value 3. And then I have stream B, which is stream A, mapped, each of these A values will be mapped to 10 times A. So if I add an event listener to that stream B, and I console log that, we will see b being 30. But now I want to change the value of stream A. And here is where a lot of people get stuck, because they want to change stream A. So they feel like doing this, set to 4 or something like this. But this is not what we should do. Why? Because A is also a dynamic value over time, and that means that we need to specify that dynamic behavior completely at the time of declaration. So this is not the time of declaration, but instead this is the time of declaration. And that's where the trick is. We need to specify not just B's behavior once, but also A's behavior once. We cannot change A later. We have to specify how A will work over time, and we have to specify that only at the time of the declaration. So if we do this, now we have an event stream that has just simply 2 events. It has the event 3 and then it has the event 4, and B will change accordingly whenever A changes. And now if we run this, we see B being 30 and 40. So the why, remember, is because reactive programming allows you to specify the dynamic behavior completely only once at declaration.